Hello, I just saw this neat animation from Bees and Bombs, and I thought this shape is the perfect candidate for a pure CSS demo because it looks very cool, and it's actually not that difficult. It's a left-handed knot, as you can see in this image, and its Cartesian coordinates. The Cartesian coordinates of one item in there is given by these equations here. So this t here is an angle, and the way we computed this angle is we divide the full circle 360 degrees by the number of items we have, and then we multiply that base angle with the index of the item, which is a crystal in the initial animation. But we're going to do something like, I don't know, a ball, because I just want to show you how to do this 3D distribution, not necessarily reproduce the whole thing. So I'm going to have 30 items here. So they're going to be balls, okay? Now here I'm going to have a diameter for a ball, which is going to be something like 1.5 ems. So for the ball, I'm going to have a width, which is that diameter. Then I'm going to have a height, which is equal to the same diameter. Then I'm going to have a background current color. Okay, what? Okay, I knew I shouldn't have tried this. This is just slowing me down. Okay, next I'm going to have div position absolute. I'm also going to do transform style, preserve 3D, margin half the diameter, so it's right in the middle of its parent. But first of all, let's put the whole assembly in the middle. So that's going to be 50% vertically, and it's also going to be 50% horizontally. Okay, now let's make this round. This is going to be border radius 50%. Okay, next thing I'm going to set a transform, and this is going to be translate 3D. And here I'm going to use a vector. Okay, now here I'm going to have for I from 0 to n, which is the total number of balls, which I haven't defined, and I need to do so here. So I'm going to have 30. Then here I'm going to compute a j, and you'll see just why in a moment. Then I'm going to have nth child. Here is j, and I'm going to compute that vector. I'm going to use a function for this. So this is going to be function v, and it takes an index and the base angle, which is going to be on the base angle I'm going to compute here, which is going to be 360 degrees over the number of balls. So this is going to be the base angle. Okay, here I compute the central the current angle, which is I times that base angle. And before I compute the coordinates, I'm also going to compute a radius, a distribution radius, which is let's say something 2 times the diameter. I hope that works. So now I'm going to have an x, which is the radius times sine of the current angle, plus, now I'm also going to define a p, which is 2, and a q, which is also 2. Okay, so here I'm going to have p times sine of q times current angle. Now I'm going to take this and copy paste it, and here I'm going to use cosine. This is going to be minus, this is going to be y, and finally here, I know it was with minus in those previous equations, but that was for the left-handed knot, and I'm going to need the left-handed one, not the right-handed one. So that's going to be sine of q plus 1 times, and you'll see why I didn't use the constants. So return x. So this is going to give me the vector. So now when I set this here, I'm going to have, so this should do it. Okay, 360 degrees. And 30. Something went wrong there. Okay, let's see. Okay, sorry about that. So I forgot to multiply with the radius here. That was stupid of me. Okay, so this is it. This is the distribution, the 3D distribution. Now let's make it look a bit more 3D. So I'm going to set some styles on the body, and that's going to be margin 0, height, make it full height, and then I'm going to set perspective. Let's make it something exaggerated, like 13 ems or something. And now you can clearly see stuff. Now let's also set a box shadow. Something like, so this should make it pretty obvious right now. Okay, so as you can see, it looks a lot more obvious. So let's say I increase the number, and this is going to be something like 72, and let's go up, make this 72 as well. Now I'm going to have something bigger. Let's make this something like 3. So it just actually let's make it 4. Oh, too big. 3.5. That should do it. Okay. I think this looks pretty good. Okay. So now that I have this, I can try to animate stuff a bit. So let's say I'm also going to compute. This is going to be the initial vector. So I'm going to use this as initial vector. And then I'm also going to have a final vector. So this final vector uses j. So I'm going to have keyframes. And this is going to be a moving animation. And this is going to go to, oops, transform, translate 3D, and it's going to use the final vector. Okay, so I'm going to set a movement animation duration, and let's say this is going to be 0.25 seconds or something like that. And then here I'm going to have animation, motion, linear, infinite. So this should do it. This should give us some motion. And since it doesn't, it means something's wrong with it. I'm not exactly sure what. Okay, so let's look at this. So these values actually look pretty good. Okay, that looks good as well. Okay, I have no idea why this isn't working. This is seriously frustrating. Okay, let's go back to the uncompiled thing. So transform, translate 3D. Seriously, it should work, because there's just oh, that's why it didn't work. That's why it didn't work. Okay. So now it works, as you can see here. Now let's make it rotate in 3D. So we're going to have something like keyframes rotate. It's going to go to transform rotate Y 1 turn. Okay, and I'm going to have the rotation is and I'm also going to have a reverse rotation, which is the rotation reverse. So I'm going to have first a rotation time, let's say something like 20 seconds. Okay, and now I'm going to set this animation. I'm going to set it at a rotation thing. So as you can see, this rotates, but it doesn't look like balls anymore. So one more thing I'm going to do is here I'm actually going to set overflow hidden. Okay, and I'm going to make the perspective less exaggerated. And then I'm going to take these styles from here, collapse this loop here. I'm going to have before and after pseudo elements absolutely positioned. Then I'm just going to copy paste those styles, remove the transform, add content empty, add an animation, which is going to be the reverse one. Okay, so this should now do it. I'm going to remove this stuff from here, remove these things from here as well. Okay, now I'm going to make this a radial gradient. This is going to be a circle at 35%, 25%, and then I'm going to have white and current color, and this gives me a SAS error unless I change that, which is kind of stupid. Okay, now by the way, Edge has a problem with using color and radial gradients this way, and so this means that the color won't change in Edge. Okay, we're going to set also a color, and this one is going to be an HSL value, which is a calc value, and this is why it's not going to work in Firefox. It's going to stay gray as you see it here. So that's how it's going to look in Firefox. It's not going to get the colors. I times, and here I'm going to have interpolated the base angle over 1 degree, because this doesn't work in the CSS HSL function. It does work in the SAS HSL function. That's a different thing. Okay. And here within the loop, I'm also going to set an I and also a J. Okay. Now I'm just going to remove this. Actually, I'm going to make it white. Okay. And then something else I'm going to do for the after. I'm going to set I to J. Oops, sorry. Like this. Okay, one more thing I want to do is here in the body I'm going to exaggerate the perspective yet again. I know, something even more so. And I'm going to set the background. Yeah, actually I'm going to leave it like that, black. Okay, so this just made my fan go crazy and I'm not exactly sure why. Okay, one more thing I want to do here is to fix the color thing. So I'm going to have a fading animation. So keyframes, fade, and I'm going to go from opacity 0. So here I'm going to have animation, first of all reverse, and then I'm going to have this fading animation, which is going to be equal to the timing is going to be equal to that of the motion, and it's also going to be linear and infinite. Okay, so this should do it. This is the finished result. This is it for today. You're going to find the link to the CodePen demo in the description below. If you have any questions or requests for future videos, you can send them on Twitter or drop them in the comments. I hope you've enjoyed this video, and if you have and you want me to be able to do more of this in the future, please consider supporting my work in one of the ways explained in the description, with a donation, by getting me something off my Amazon wishlist, or at least by sharing this to show the world what can be done with just CSS these days, because I think it's pretty damn cool. In any event, thanks for watching.